Hi. So for question 15, we've been given the equation of curve C. We've been told the point P, 4, 6, lies on C. And we've also been told that the line L is a normal to C at point P. And we've been asked to show that the area of R is 46. Okay, so this area R is the area bound by the curve, the line, the x-axis, and the line x equals 2. Okay, so I haven't mentioned that just purely due to space, but it also says that in the question. So just to give you a brief overview of what I'm going to do, the first thing I'm going to do is I'm going to split up this area R into two distinct regions, the green one and the red one. Okay, so I can call this green region A1 and I can call this red region A2. Okay, and I know this point here is 4 and I know this point up here is 6. Okay, so I'm just labeling in my coordinates and I split up my areas. Okay, so to find the area A1, I'm simply going to integrate this curve between the limits of 2 and 4. And then to find the area of A2, which is a triangle, if you notice it's a right angled triangle, so I can just do half base times by height. Well, I know the height and I need to find out the base. Okay, so how do I find out the base? Well, I need to know this coordinate here. So how do I find that coordinate there? Well, I'd need to know the equation of the line. And then how do I find the equation of the line? Well, it's going to be due to the fact that the line is normal to C at the point P. Okay, so what I'm going to do to find the equation of that line is I'm going to differentiate the curve. I'm going to substitute x equals 4 into it to find the gradient at that point. Then I'm going to find the negative reciprocal of that gradient because I know that this is the normal, so it's perpendicular. And then I can find the gradient, and I know a point that this line goes through, so I can find the equation of that line. Okay, so I can start off now by saying that y is equal to 32x to the minus 2 using my indice rules plus 3x minus 8. Okay, so all I've done here is I've just written out the equation of the curve and I've just used my knowledge of indice rules to bring up that x squared, okay, to make it easier to differentiate. I can now therefore say that dy by dx equals minus 64 x to the power of minus 3, okay, timesing by the power and then subtracting 1 from that power again. Okay, so 3x differentiates to 3 and constants simply differentiate to 0. Okay, so now, as I said, I want to find the gradient at the point where x equals 4, so I'm finding the gradient at P. So when x equals 4, dy by dx is going to be equal to 2. Okay, so I know that the gradient of line L is perpendicular. Okay, so I'm just going to write that. I can say the gradient of L is perpendicular. So I can therefore say that the gradient M is minus a half. Okay, so now using y minus y1 equals m x minus x1, which is a formula you should know in order to obtain the equation of a line, I can now say that therefore the equation of L is y minus 6 equals to minus a half x minus 4. Okay, so you could rearrange that now and find it in the form y equals mx plus c, but you don't really need to do that because we just want to know where this line crosses the x-axis, and at that point y equals 0. So I'm simply going to substitute when y equals 0, find x. Okay, and if you compute that, you should get a value of x equals 16. So now we know that this point here is 16. Okay, so to find the area of A2, it's a right angle triangle. Okay, so we can just do half base times by height. We know the base is the difference between these two coordinates, so the base is 12 and the height is 6. Okay, so the area of the triangle is going to be half times 12 times 6. Okay, and you should get a value of 36. Okay, so now we can find the area of A1. So, like I said before, in order to find the area of A1, this green section here, we can just integrate this function. Okay, we can just integrate this curve between the limits of 2 and 4. Okay, so we're simply going to be integrating the function between the limits of 2 and 4. Okay, so again, using my indice rules, I'm just going to write out 32x to the power of minus 2 plus 3x minus 8. Okay, and we're differentiating with respect to x. Okay, so 32x to the power of minus 2, I add 1 to the power, so we get 32x to the power of minus 1, and then divide by minus 1. 3x integrates to 3x squared, and then divide by that power, divide by 2, and minus 8 integrates to minus 8x, okay, between the limits of 4 and 2. Okay, so if you substitute those in, you should get 32 multiplied by 4 to the minus 1 divided by minus 1 is minus 8. 4 squared is 16. 16 times 3 divided by 2 is 24, plus 24. And then minus 8 times by 4 is minus 32. Okay, and we are subtracting from this second part. 32 multiplied by 2 to the minus 1 divided by minus 1 is minus 16. 3 times 2 squared over 2 is 6, plus 6. Then minus 8 times by 2 is minus 16 again. Okay, so if you compute that in the calculator, you should get a value of 10. Okay, now to find the area of R, therefore say area of R equals A1 plus A2. So that's 36 plus 10. I'm just running out a little bit of space here, so I can just write out the answer here. I'm going to say the area of R is 36 plus 10, which is 46. Okay, and if you like, you can just write units squared, okay, because we know that this is an area. Okay, so thank you very much for watching, and if you need help with the topic of integration, please find below in the description links to a few different tutorials and exam questions. And don't forget to like, comment and subscribe. Let me know how I did, and let me know anything else you want to see from me on this channel. So thank you very much, and that's the end of the paper.